in the cloud, and we are recording. Okay, so thanks everyone for joining today. We've invited Manny from the Linaro Developer Services team to talk to us about LoRa and Zephyr. So I'm going to hand it over to you, Manny. Thank you.
Hey, thanks a lot, Vicky. Hello, everyone. So myself, Manivannan Sadhasivam. I work as a kernel engineer at Developer Services team of Linaro. So I contribute to Zephyr in my spare time. So I mostly do the SoC and board supports. So I was previously at 96 boards team of Linaro, so that explains why, because we had a lot of boards there. And I do maintain the LED API in Zephyr, which is pretty small and basic. But recently, I got a chance to work on LoRa Support in Zephyr. And that's what the talk is all about. So let's get started. So this is the agenda for today's talk. I'm not going to cover the entire basics of LoRa, or this is not a deep dive session on LoRa. Instead, I'll be just talking about the LoRa implementation in Zephyr, a bit of history of what happened, and what's the motivation behind that. And also, I'll just talk a little bit about the future goals, what we want to achieve. And then I'll also talk about the community, which is growing around this LoRa or LoRaWAN effort in Zephyr. Okay. So what is LoRa? So LoRa is an acronym of long range. So it's basically a LPWAN wireless technology based on the chip spectrum modulation technique. So this modulation technique uses the chip pulses with the linear variation of frequency to encode information on a medium, which is air. So LoRa is based on that modulation technique. LoRa uses a slightly modified version of CSS modulation. So it's not entirely CSS. And LoRa operates in the license-free sub-gigahertz frequency range, which of course varies with locations, and which is so this LoRa
I'm sorry,
sure.
Manny, you dropped out momentarily. You were talking about the frequency range.
Oops, sorry, I don't know what happened.
No worries.
Yeah, so actually LoRa operates in a license-free sub-gigahertz frequency range, which varies with locations. So we have 865 megahertz allocated for LoRa in India, and 8 in Europe, 915 in Australia, etc. Just let me know if I'm dropping. So this LoRa technology was originally developed by Cycleo. So it was a company based on France. So there were a team of 3 like-minded people wanted to develop a communication technology for metering applications. So that company got later acquired by Semtech, and Semtech helped them to develop the first LoRa radio, which is SX1272 and then SX1276 later. And also, Semtech developed the LoRaWAN, which is a MAC protocol to provide true networking support to LoRa. So since LoRa is pretty much the radio stuff, you cannot do any more networking with only plain LoRa. So that's the motivation behind developing this LoRaWAN stack. And finally, a LoRa alliance was formed with the interested parties to support and promote the LoRaWAN adoption globally. And this effort is still spearheaded by Semtech, but it's coming through the LoRa Alliance now. So this is the network topology of LoRaWAN. So as I said before, LoRa is just the PHY layer. So in terms of OSI. And LoRaWAN is the max soft layer because I think I need to move this thing. Okay. So LoRaWAN is just the max soft layer because I haven't really seen any physical implementation of the LoRaWAN protocol. It's mostly, it will be a stack running on the target MCU, which is controlling the end node. So that MCU will talk to the LoRa PHY using SPI communication protocol, and then it will transmit the data, etc. So the LoRa protocol is closed. It is proprietary to Semtech, but the LoRaWAN stack is open, which means the specification is open, and also there is a reference implementation available in the Semtex GitHub repository. So anyone can just use it without paying anything, but the only catch is that they have to use the LoRa radio for transmitting the data. But I have seen some pretty interesting works, like using this LoRaWAN stack on top of BLE. So actually, you don't need to pay for the LoRa anyway. And so LoRaWAN works in the star topology, which means all the end nodes need to communicate to the centralized gateway, transmitting the data. And then the gateway will in turn relay all the messages to network server and the application server. But when you take the LoRa PHY alone, you can do P2P between two end nodes or between an end node and a gateway. So that won't involve any sort of networking communication. It's just transmitting and receiving the data plainly. But if you want that, then you need to have the LoRaWAN in place. So in LoRaWAN, the communication between end node and gateway. So end node and gateway happens through LoRa technology. And then the communication between gateway and network server happens through the standard TCP/IP mechanism. Okay, so here comes why Zephyr needs LoRa. So I'm just presenting here an industrial application perspective. So when you want Zephyr to be the RTOS for industrial applications, you need true multitasking support. And that's what this guy is doing here. And we do have the multitasking support in Zephyr. So this is ticked off. And then we need to have the MISRA CE guidelines adopted. So this effort has been started in Zephyr, even though there are still debates going on whether this MISRA CE guidelines should adapt to all the source code or apart from kernel, and also whether we should use all the guidelines in the MISRA, all the rules in the MISRA guidelines. So it's still debatable, but we are progressing, and I'm pretty sure that in some point of time in future, Zephyr will become a MISRA CE guideline compatible RTOS. We'll see that. And of course, we need to have the security in place, and Zephyr is pretty good in terms of security. I can say that because we have our own security guidelines, and there is a support for cryptographic algorithms based on external repositories like TinyCrypt or EmberTLS. And it's pretty good in terms of security when you compare it with other open source RTOSes. But the only thing which is not in place for Zephyr to be an industrial grade RTOS is the communication technology. So we do have support for a few communication technologies like Bluetooth, Wi-Fi, etc. But those really fall into the 2.4 gig frequency band, which is overly crowded and then prone to interference. So what the industrial applications want is a wireless communication technology in a less polluted space. That's where LoRa comes into picture. And since it operates in the sub-gigahertz frequency band, which is not at the moment overly populated because the world just went with 2.4 gig. So that makes LoRa a perfect choice for industrial applications. And when we add LoRa support in Zephyr, we can say that Zephyr will become a best bet for an industrial grade RTOS. So that's the entire motivation behind adding LoRa support in Zephyr. So if you have any questions, feel free to interrupt me. Okay, so here comes the history. So the part one actually covers the effort taken by other community members, not me. So it's just a prehistory of me. So the first issue for adding LoRa support in Zephyr was opened by a community user back in 2017. So he just opened a PR issue to discuss whether is there any plan to support LoRa in Zephyr or not. And then later, a couple of folks jumped in and then shared their views. They expressed their interest in adding LoRa support in Zephyr, and then the discussion went on. And later, Kate Stewart from Linux Foundation, also in the Zephyr chair, she opened a feature request issue on Zephyr for adding the LoRa WAN or LoRa radio support. So she mentioned industrial applications is one of the use case of adding LoRa support in Zephyr. And that's correct, yeah. So after some time, Ding Tao, one of the community user, opened their first RFC PR to support LoRa WAN. It's not LoRa, he just directly supported LoRa WAN. So that pull request was just plainly opened without no intention to merge it to Zephyr mainline. So he mentioned that clearly, but he was open if someone could take that and then make it ready to get merged into Zephyr. But he had no intentions to merge this by himself. So that's why he has added he had added no API and board support. It was just a plane of commits which just included the LoRa Mac reference implementation from Zephyr, from Semtech, and then he had a couple of commits for adding the SX1272 and SX1276 LoRa radios. So there was a bit of discussion happened on the API design, how we want to integrate this LoRa support in Zephyr, etc. And after some time, the PR got closed by the author. So that's somewhat disappointing. And here comes the part 2. So this part 2 covers the effort taken by me for adding the LoRa support in Zephyr. So I have opened the RFCPR to discuss the basic LoRa API implementation. We should note that I hasn't opened a PR to add LoRa WAN support. I just wanted to have the LoRa support in place, which is just the radio or PHY for doing the basic P2P communication. And then later on extending that to LoRa WAN, because I always work with start small and then build it big principle. Okay, so I proposed the basic LoRa API and then the design to the community. So I also used 96 ports Vistrio as the target platform, because at the time, that was the only board which had LoRa and it had Zephyr running. So I still have only one. Okay. So I have reused the Semtex reference code, which is the LoRa Mac node repository in my original implementation. So my idea was to use Semtex repository only for the Mac layer implementation and not for the radio and stuff, etc. For radios, I wanted Zephyr to host the native drivers, but that idea was turned down. And Thomas, I don't know how to pronounce his last name, but he nacked that PR, asking me to reuse the LoRa Mac node repository for the radio also, because he was right, because he wanted to avoid the code duplication, because it already had the radio driver and it makes sense to reuse that. So I was confused. And then, okay, I just accepted that. And then I went back to rework my design. So back to the drawing board and initial idea. And then later, I came up with another version of the PR. So this time I had reused Semtex stack, so which was pretty good. So I added a glue driver for interfacing with the Semtex repo and then Zephyr. And then still, there was no LoRa WAN support added. I was just concentrating on LoRa API at that moment. And I had added Semtex LoRa Mac node repository as a Zephyr module, because I talked to a few people, and then like Carlos from Nordic, and he suggested me to add it as a module, because that's the proper way of using an external repository in Zephyr. So this time I got positive reviews, and I have splitted the board specific parts from that PR, and then we merged them separately. So I should thank Erwan for giving that suggestion. It just speeded up the process. And roughly after 3 months, the PR got posted. We finally merged it to mainline Zephyr, and then I had some sort of excitement. Yay. Okay. So here comes the LoRa implementation detail. So this is the basic API providing the P2P support. So we had API for configuring the modem, And then we had APIs for sending and receiving data. It's pretty simple. Just three APIs making use of the entire LoRa radio. So the initial flow I had in mind was configure the radio for send or receive, and then just send or receive. But if you want to change the functionality, like if you have configured the modem for sending, but if you want to make the modem receive, then you need to do the configuration once again. So this is one of the design decision I took at that time in order to keep the API simple. But I knew that it won't scale because the users only want to configure the modem only once, and then they'll need to send or receive at any time later. So this is going to get changed. We are having discussions in our community, in the Slack channel, about modifying this API. And to aid this purpose, I have marked this LoRa API as experimental so that all the changes can be made easily. So Zephyr has the way to do that cleanly. All right, so here is the configuration structure used for configuring the modem. So the frequency parameter determines at what frequency the modem is operating. So it will become 865 for India and 868 for Europe, etc. And there is a bandwidth parameter in there. LoRa is pretty strict in terms of bandwidth. So there are only 3 bandwidths allowed, 125 kilohertz, 250, and then 500. So you need to choose anyone on that, among that. And then we have data rate. So data rate in LoRa is actually corresponds to the spreading factor. So spreading factor is just the time on air. So if you have the spreading factor as low, it starts from 7 and goes up to 12. So if you have the spreading factor equal to 7, the data can be transmitted more fastly, but it won't reach longer distances. So if you want to cover longer distance, then of course you need to increase the spreading factor, and then in turn, the data rate will get reduced. So this is just a trade-off in LoRa. You need to choose your use case. I mean, you need to choose depending upon your use case. So we have coding rate. So coding rate is just the portion in the transmitted bits which contribute to the payload. So you need to choose that depending upon your use case also, of course. And then there's preamble length, TX power, and then TX flag. So this TX flag is internal to Zephyr. This is used for configuring the modem for TX or RX purposes. And of course, this will get removed when we revoke the API in future. So, okay, I mentioned that we have, I had reused the LoRa node, which is the reference repository from Semtech. But I had built that module as a library in order to avoid the namespace issues, because there are many symbols which were more common between the LoRa node repository and then Zephyr, because LoRa node is used as a standalone repository for the application development. So of course it has a few symbols which were defined in both of the repositories. So I had to build it as a library in order to avoid those issues. And thanks to Alexander Wachter, because he really gave me that suggestion to do that, because I never know that these kind of things existed in Zephyr. This is pretty good. Okay, so I recently, I had submitted a pull request for adding the LoRaWAN support in Zephyr. So the basic idea is that LoRaWAN will live as a subsystem under subsys hierarchy. So this LoRaWAN support will reuse the existing LoRa drivers based on the LoRa API to send and receive packets. And then we don't need to modify anything in the Zephyr LoRa node module, because we are just reusing all parts of the code without doing any modification in the original repository. So we have a strict policy, like if you want to modify anything in the LoRa node repository, then you need to do it upstream first, and then only then you can inherit in the Zephyr module. So we can't really touch anything to make it messy. So, but we need to enable few drivers in that repository, but that's done separately without touching the core repository. But the only thing which is tough in LoRaWAN is the API design, because LoRaWAN is somewhat complex, and designing an API is hard, because LoRaWAN is a mixed bag of synchronous and asynchronous operations. Because when you send any data, that is synchronous, but the receiving is almost asynchronous, because we have classes, we have different time slots for receiving the data. If I want to talk about that, then I need to explain the whole LoRaWAN specification. I don't want to do that, but I have added the LoRaWAN specification in my speaker notes. Feel free to check it out later. So, and then there are blocking and non-blocking operations in LoRaWAN. So some of the send and receive can block. Block in the sense it can wait for getting the confirmation from the gateway or network server, but some of the operations can just return without blocking. Just send the data, return. So we have different sort of combinations in the LoRaWAN. So designing a common API is somewhat tricky. So still we have the discussion ongoing, and hopefully we'll reach a conclusion sooner. And then we have the whole different problem of storing the keys and states in the local end node. Because the end node is not so smart, basically there will be a Cortex M0 or M3 MCU running in the end nodes. There won't be any provision for adding the TPMs or any sort of security modules for storing the keys. But LoRa MAC node reference stack has a soft secure element implementation, which is used for storing the keys, etc. But I guess right now I'm just reusing it in my open PR. But we are having discussions on how to use the existing storage implementation. I think we have storage subsystem in Zephyr, and we are discussing on how to use that subsystem for storing the keys securely. And then if there are any hardware accelerators, how can we get benefit from that? So we are discussing that. All right, I think this is going to be the last slide. The session is pretty short. So we do have a community for the LoRaWAN effort in Zephyr. So that is a Slack channel created by me. It's called Zephyr LoRaWAN. Feel free to join. And we have more active members now, because when I opened the Slack channel, it was only me and then a couple of developers. But right now it's just growing, and then it reached 17. So more members started to join, and then more importantly, they are willing to contribute to this effort, which is pretty good for me, because I won't work on the LoRa support full time. It's just my spare time thing. So since they are very active in contributing, I was more happy to just review and then make things go smoothly. So a couple of them already submitted PR for improving the LoRa support, and there was a existing PR to add SX126X radios, and then there was a proposal to add more boards to the more boards using the LoRa and Zephyr. So that's good. And then I'm pretty sure that once we add this LoRaWAN support in Zephyr, the activity is going to get increased, because if only LoRa, we can't do much, but only once we open the LoRaWAN support, I think it will attract a lot of people, and then more companies may start to invest their time and effort to make this support better. And then they might even use this LoRa and then Zephyr implementation in their end product. So that will pave way for that. All right, that's about it. Is there any questions for me?
I'm curious if, are you aware of any MCUs that actually have the Semtech radio integrated in them, either like a roadmap?
So I think SD has released something. I haven't deeply looked into that, but I have seen in the PRs like a whole MCU with integrated radio and such. But I don't really know the internal details of it. But what we have now is just a module. Like in the Vistrio board, we have a module called RAC 811. It's a kind of SIP module where you have the MCU and LoRa radio integrated. So.
Yeah, that always just seems like the issue that I always hear come up again and again, that you're limited to Semtech radios and there's no MCU that integrated like there is with, say, BLE and 802.15.4 with Nordic chips or whoever else.
Yeah, that's right. Yeah. Right
And,
now,
and
yeah.
sorry, go ahead.
Yeah, but right now, Semtex is just the main key player in developing the LoRa applications, LoRa solutions, because of course they own the design and the modulation technique. So,
but that's the reason why I always hear people not wanting to adopt LoRa, is that they're afraid that it only depends on a single vendor using a single chip,
yeah,
or two
yeah,
chips. But that's, yeah,
that's
everybody
true. Yeah.
finds the technology interesting, but they're afraid of Semtech just depending entirely on them. So
Yeah, and yeah, like I mentioned before, I have seen use cases where the LoRaWAN stack gets reused on top of BLE. So
yeah, that was interesting.
that's also an option.
If you have a link or something, I'd be interested to see what they're doing there.
Yep, sure. I think I read it somewhere. Maybe I can dig it out and share it with you later.
Sure, yeah, I'd be interested, just because the advantage of BLE is every telephone and then 3/4 of the mobile devices that there support BLE. I do like LoRa, but it's an interesting combination to be using some.
Yeah, true that.
Okay. Have you done any tests with range also? Because LoRa sounds nice on paper and they make a lot of big promises about range, but
Yeah, sorry, I haven't really done any test, but everything what I read on range is theoretical. And of course, we do have our partners. Rack Wireless is one of the 96 boards partner developing the LoRa solutions, and they have done some on-field testing, but I haven't done that personally. And it really depends on the environment you're testing.
Yeah, absolutely. Anything RF, but it's just I haven't tried myself, so I have no opinion. I've just heard that maybe it tends to get oversold, the range, because it's sort of this perfect ideal situation where they talk about kilometers of range. But
yeah,
even with 868 or 915 megahertz, you can get good range. Even with low power, like 20-30 milliamps, you can still get pretty good range, and it penetrates much better through concrete than 2.4. So it's good for urban environments, but the range seems to be really oversold. It's
right.
still quite good, but I was just curious if you had any experience.
Yeah, I don't really have that. I mean, most of the people just say that it just supports 10 miles, which means 15 kilometers. But I don't know.
That seems like a crazy number to me.
Yeah,
You'd
that's
have
right.
to have a really high transmit power in any sort of real. If you're in a farmer's field, okay. If you're in Idaho, I don't know. But
yeah,
if
I don't
you're
know
in
what kind of. I would be curious to see the antenna they were using.
Yeah, if you're in like the Grand Canyon, standing on the top of a canyon, and someone else on the top of another canyon direction.
Yeah.
Okay. No, I'm just curious. I've been interested in LoRa for a long time, so it's nice to see some work here. I just joined the channel, so
Sure.
I think I'll try to keep up with it. But the big issue seems to be just the limited silicon options, and people would
that's right.
maybe, but people are a bit afraid of Semtech and depending entirely.
Yeah, and I have read the news somewhere that they have started to produce 2.4 gig gigachoice. So they were starting to move from this sub-gigahertz frequency range. And then I don't know whether that's effort is to make this entire stack work with the BLE kind of thing. I don't know. But Semtech made some announcements some time back, but I haven't really seen any news after that.
Okay. I mean, sub 1 gigahertz makes a lot more sense to me, especially for the kind of market that they're going after with industrial applications. You don't want to be in 2.4.
Yeah.
I would like to see more things in like 433 or 434, but anyway. Yeah. 868 and 915 always seem good. I'm just always on the fence between, should I invest in LoRa or should I stick to generic 802.15.4? In which situation, maybe you don't get some of the fancy features, but you have multiple.
Yeah, LoRa seems to be a better option for if you want to do some IoT applications, because their entire stack is just made for IoT, I would say, because we have the concept of network server, application server, and then you can control the data flow using the application server, which just fits nicely for the IoT ecosystem.
Okay. And do you still have the idea a 15.4 that you get an acknowledgement, you know if a message arrived or not, because some protocols don't have that. But if I send a message with just base 15.4, I will know if that arrived or if it didn't arrive. Do you have that sort of reliability with LoRa?
Yeah. So as I said okay, I think here.
We don't necessarily really.
I don't have this written. So that is a thing called confirmed and unconfirmed messages. So that way you can get the confirmation from the network server that network server has got the message from end node, etc. So it will send you an acknowledgement message, and then you can wait for that. Basically, the LoRaWAN stack will do the offloading for you. So if you want to send a blocking send, then it will make sure that it gets the acknowledgement from the network server. Else, it will return the appropriate error code.
Okay. Yeah, I always found that useful and important with 15.4, and it's missing in some other protocols. But it's when just the nature of RF, you often need and want to know, did this arrive or not, and respond accordingly. Okay.
Yeah, and I still have an idea to implement the socket API on top of LoRaWAN. So once this LoRaWAN support gets in, I may want to add that socket API, but that is going to be somewhat challenging because the payload size is quite limited in LoRa or LoRaWAN. So of course we need to use some fragmenting and then a compression mechanism, which is not available in Zephyr. So I was planning to use the SCHC, which is static header compression method for actually sending the IP packets over LoRa. I don't know if it really helps, but that seems to be a pretty nice, spare time work for me, spare time project.
Yeah, I think it'd be an interesting idea. What is the maximum packet size with LoRa? I haven't looked at it.
Yeah, that varies from region to region. I think it can go up to 220 bytes, etc. So that really depends on the region you are in, and then the data rate, and then the frequency. I mean the TX power, etc. So there's not really a maximum size I'm really aware of, but it's in the 200-ish bytes range.
Okay, good to know. I guess that was it for my questions. I don't know, maybe someone else has some questions.
So, Manny, if things continue the way you want, when do you? What's the target for getting this into Zephyr? Is it?
You mean the LoRaWAN?
Yeah, the LoRaWAN. Yeah.
Yep, I think we should be able to do that maybe for the next release or so, not to 2.3.
But post 2.3, so sometime this year.
Yeah. Because I was really targeting 2.3 back when submitted the LoRaWAN PR, but it really depends on my bandwidth as well, because as you know, I'm not working full-time on it, so it depends on how much time I get for doing this stuff, etc. And since the community is growing, I think the process will speed up in future, and more people started to contribute, and yeah, that will going to help.
What are you using for hardware actually, just so I can try to get my hands on maybe 2 or 3 boards?
Okay, so I'm using this board, which is called 96 boards Vistrio.
Okay.
So this is one of the IoT platform of 96 boards. Yeah, it has the Zephyr running, and it has been ported to run LoRa on Zephyr. So everything is working fine on this platform. And I know a couple of folks in the community already use it for testing.
And that has the LoRa module on the board, or I would have to buy those as well?
No, it's pre-integrated. So you just buy the board and you're good to go.
Maybe I'll see if I can pick up a couple of them just to play with this myself.
Yeah. Either you can buy a couple of the boards, because with the single board, you can't do much. Either you need to buy a gateway and a Vistrio board, or you need to buy a couple of Vistrio boards to at least do the P2P. I would recommend you to buy a gateway. So if you go to the Rack Wireless website, which is the vendor for this board, they do sell gateway also. So you can just buy it in a club or something.
You can't configure the Wistro boards as a gateway. You need a specific. Okay.
Yeah,
I guess 'cause
that's right. Just an end node.
Okay, that's fine. Good to know.
Okay, any more questions? Or should I just stop the screen share?
Yeah, you can stop the screen share and I'll turn the recording off.